You will be expected to write a balanced chemical equation for the combustion of a hydrocarbon. For example, write the balanced chemical equation for the combustion of heptane, capital C subscript 7, capital H subscript 16, in the liquid phase. Pause the video to see if you can write this out. First, we write out the unbalanced equation. We know that combustion means reaction with oxygen, so heptane and oxygen are the reactants. We also know to assume that the amount of oxygen is sufficient to form carbon dioxide, and water also forms. The unbalanced equation reads capital C subscript 7, capital H subscript 16, parentheses L end of parentheses, or liquid heptane, plus capital O subscript 2, parentheses G end of parentheses, or gaseous oxygen, arrow or forms, capital C capital O subscript 2, parentheses G end of parentheses, or gaseous carbon dioxide, plus capital H subscript 2 capital O parentheses G end of parentheses, or water vapor. Let's balance carbon first. Since there are 7 carbon atoms on the reactant side and only 1 carbon atom on the product side, we need 7 carbon atoms on the product side. By placing a coefficient of 7 in front of the chemical formula for carbon dioxide, we now have 7 times 1, or 7 carbon atoms on the product side. This coefficient of 7 also affects the number of oxygen atoms, but will balance oxygen last. Now let's look at hydrogen. There are 16 hydrogen atoms on the reactant side and only 2 hydrogen atoms on the product side. By placing a coefficient of 8 in front of the formula for water, we now have 8 times 2, or 16 hydrogen atoms on the product side. Now that our carbon and hydrogen atoms are balanced, let's tackle the oxygen atoms. Both products have oxygen atoms. There are 7 times 2, or 14 oxygen atoms from the carbon dioxide, and 8 times 1, or 8 oxygen atoms from the water. 14 plus 8 is 22. To get 22 oxygen atoms on the reactant side, we place a coefficient of 11 in front of the formula for oxygen. Let's double check our atoms. For carbon, 1 times 7 is equal to 7 times 1. For hydrogen, 1 times 16 is equal to 8 times 2. For oxygen, 11 times 2 is equal to 14 plus 8. Our equation is balanced, and the coefficients of 1, 11, 7, and 8 have a greatest common factor of 1, so the coefficients do not need to be reduced.